Okay, in this video I will maybe not solve, but we'll talk about question 4 from a practice set questions for midterm 2. And it's a question about kind of the tests, your understanding how this overall the matching markets work. So it's effectively a question about being creative, creating preferences such that a certain criteria, certain property is satisfied. So for example, part A asks you a marriage problem. So you have 3 men and 4 women. So we have M1, M2, M3, W1, W2, W3, W4. And it basically asks you, well, can you write down preferences such that the stable match is unique? That's actually pretty cool questions in a sense. And you have kind of similar questions in problem sets to test your understanding under what conditions the set of stable matches is small or large. And in class, we discussed it at length. And what I said is essentially, well, to have a single stable match, what you need is homogeneity of preferences so that people like the same people. So like high school, where everyone kind of ranks people in a very similar way, that what generates a very small set of stable matches. A different way to generate only one stable match is to have basically have a lot of top-top couples who will have to be together by the standard argument. So that's what I think the approach I took when writing answer key for this. So if I want to create a single stable match for this market, how about M1 ranks W1 first, and maybe doesn't even rank anyone else who, like, I don't really care. And let's go and rank M2 ranks W2 first, M3 wants to be with W3, W1 wants to be with M1, W2 wants to be with M2, W3 wants to be with M3, W4 wants to be, I don't know, with, let's say, M1. Well, if that's only our preferences, notice that essentially everyone just ranked one person from the other side of the market, but that's already enough for me because I know that whatever I write further doesn't really matter because in this market, it's only possible to have one stable match. Why is that? Well, because I see that M1 and W1 have to be together because if I don't put them together, they will run away with each other. They are top couple. They point at each other. They want to be together. We have to have them together. We have top couple here. We have top couple here. Done. We any stable match would have to match M1, M2, M3. We don't have any more men left. So clearly it's possible to write down preferences in this market such that stable match is unique, and it's very easy to do. So I think that's what I did in part A, but I kind of expanded and I have a lot more preferences there. Now in part B, we consider the same problem, but specify preferences such that there exists a stable match with a single couple. Everyone else stays unmatched. Okay, so let's try to do that. How about we only need one couple to be matched. So let's have one top couple. Suppose then M2 points to W2 and M3 points to W3, but, and let's say this is the only people they would like to be with, but W2 also wants to be with M1 and maybe whatever, well, let's say M3, and W3 doesn't want to be with M3, so suppose also M1, maybe M2. And W4, let's say also M1. Well, then it's pretty clear that we will have one couple, top couple here, and then the only person we can match M2 with is W2, but W2 doesn't rank him. Therefore, M2 will be unmatched. M3 can only be with W3, W3 doesn't rank him. Therefore, M3 will be unmatched in any stable match. And we just proved that essentially we will have one single stable match here, and there will be only one couple matched there. There will be only one couple, M1 and W1. under these preferences. I think it's relatively clear. So these questions you can write down a lot of different preferences, but we are looking for the simplest way to show you the result. So it's very easy to write down preferences. So here, preference give you one stable match, and in that stable match there's only one couple because everyone else have to stay unmatched. The reasoning is because M1 is matched with W1, M2 will be unmatched, M3 will be unmatched, therefore our women have nobody to be matched with. All right, part C, roommate problem. So we go away from the marriage problem and we go to roommate problem. And we say, okay, we have a roommate problem with 4 students and 2 rooms. So we need to put them in couples into rooms. Specify preference such that the stable match is unique. Well, that's relatively easy. Let me change this. So we have 4 people. And again, if I need one single stable match, the easiest thing for me to do in a roommate problem, I have to rank all other roommates. So for example, I can rank P2 first, then P3, P4. P2 ranks P1 first, P3, P4. So what I did here is I created top-top couple because these 2 people really wants to live together. And I'll do the same here. So P3 wants to live with P4, and P4 wants to live with P3. And for these preferences, I claim that stable match is unique because these 2 people wants to live with each other, these 2 people wants to live with each other. There's only one decent outcome for this market, where we put these people in room 1 and these people in room 2. Okay, and finally, we are asked to construct preferences for roommate problem for the same problem such that no stable match exists. That's a result we already seen in class. Remember with the friends cast example, I illustrated that stability is not something given for granted. It's actually in a decent market, it's possible that it doesn't exist. So let's just replicate it here. So the way that example worked is that there was one person that everyone hated. So let this person be person 4. So let's say for P1, he wants to live with P2, then P3, then P4. And P2, so to avoid creating any couples, we want conflicts. So P2 would actually prefer to live not with P1, but with P3, then P1, then P4. And finally, P3 wants to be with P1, then P2, then P4. And for P4, whatever, doesn't care. So claim is that no stable matches here. Why is that? So let's repeat that argument. Well, kind of look at these 3 guys. We have 2 rooms, so one of them will have to live with P4. So that person will be miserable. And that person will always have somebody to run away with in another room, because suppose we put P1 and P2 in one room, and P3 and P4 in other room. Then P3 hates it. He wants to run away with. And there is a person in another room, namely P2 here, that really likes to be with him than with his current roommate, who is here. So let's say like P3 and P2 block. And so for any configuration you choose, the same will be true. So that's exactly the example we used in class to generate this result. Okay, so I hope that was instructive enough. So kind of do pay attention to these questions. I gave them in a slightly easier questions like that on a test, and check out how I structure this question on Canvas in a practice test.